Hello students, continuing to learn geography, passing on to a new chapter, rotation and revolution. Let's see what's there in the syllabus. Rotation, direction, speed and its effects like day and night, sunrise and sunset, Coriolis effects, revolution, revolution of the earth on its inclined axis, Earth's inclined axis and its effects like variation in the length of the day and night, seasonal changes with equinox and solstice. Students, as you all know that the planets in the solar system move around or goes round the sun. The same way, the earth is also one among these planets that revolve around the sun. But there are two basic motions. One is known as the rotation and the other one revolution. Rotation is the movement of the earth on its own axis from west to east, whereas revolution is the movement of the earth round the sun in an elliptical orbit. Earth revolves around the sun in an elliptical orbit and rotates on its inclined axis. Rotation and revolution are the two motions of the earth. Day and night and seasons are the effects of the earth's motion. Students, rotation of the earth. As you all know that the earth spins on its own axis from west to east. So it takes around 24 hours to complete one rotation. The two end points of the axis is known as the north and the south pole. North and the south pole. The axis is tilted at an angle of 23 degrees with regards to the perpendicular. The tilt of the axis is 23 degrees with regards to the perpendicular from the base. Characteristics of rotation. So Earth takes around 24 hours to complete one rotation. 24 hours means 23 hours, 56 minutes and 4.09 seconds. The Earth doesn't change its inclined axis during revolution. This is a very important point to be noted. The speed of the Earth is greater at the equator than the poles. This is because of the wider circumferential area of the Earth along the equator. So hence the movement of the Earth is felt more along the equator. Now the effects of the Earth's rotation. Occurrence of day and night. Students, you look at the illustration. The part of the Earth facing the sun has day. Can you see the sun rays falling on the part of the Earth is day? And the part that doesn't face the sun has night. This is because the earth is spherical in shape. With regards to day and night, the sunrise is known as the dawn. When the sun is exactly overhead at noon is known as noon. And the time when the sun sets is known as the dusk, or it is also known as twilight. As the earth rotates on its inclined axis, so the day and night are not equal everywhere. So please bear in mind, there can be a question. Why is it a fact that the length of the day and night is not even everywhere? Your answer must be the earth rotates on its inclined axis, so hence the length of the day and night is not equal everywhere on the earth. Sunrise and sunset. The earth rotates from west to east. The part of the earth that moves from the dark to light experiences sunrise. So that's the reason why the sun rises from the east, because the earth rotates from west to east. So hence the sunrise is experienced along the eastern zone. The part of the earth that moves away from the light experiences sunset. Coriolis effect. is the pattern of deflection taken by the objects not firmly connected to the ground. This is very simple, students. As the earth rotates from west to east, so there is a great impact of the rotation of the earth and the shape of the earth. Because of the spherical shape of the earth, the air masses or the wind gets deflected. When the earth moves from west to east, the direction of wind is from east to west, but because of the spherical shape and the greater circumferential area of the equator, the air masses gets diverted or deflected towards the right in the northern hemisphere and to the left in the southern hemisphere. So this is known as Coriolis effect. So Coriolis effect give rise to wind and ocean currents. Effects of the Coriolis force: clockwise movement of wind and the ocean currents in the northern hemisphere, and anti-clockwise movement of the wind and the ocean current in the southern hemisphere. There are also other effects of the Earth's rotation, like the sun, moon and the stars appears to move from east to west direction because the earth moves from east to west. Hence all these celestial bodies appears to move in the opposite direction, that is from east to west. The movement of the earth, which is resulted in the bulging of the earth at the center, is known as the centrifugal force. Because of the earth's rotation and the wider circumferential area or the greater circumferential area along the equator give rise to widening of the area. So that's the reason why the earth is bulged at the center, and it causes difference in time variation by 4 minutes. As you would have learned in your previous chapter, that every latitude and a longitude represents 4 minutes. So the movement of the earth has an effect in the difference in time by 4 minutes. And this also causes variation in temperature and the season. This is because as the distribution of the sun's heat and light is not even everywhere, so this give rise to convection currents, and this give rise to the movement of the air masses and the ocean currents that bring about changes in the temperature and give rise to seasons. Significance of the Earth's inclined axis. What if the Earth had rotated on the vertical axis? There would have been equal day and night and equal temperature everywhere. Now that the Earth rotates on its inclined axis, there is difference in the day and night. The duration of the day and night is not equal everywhere. The temperature reduces from the equator to the poles and give rise to the season. Here in this illustration, you could just observe this is the equator. The earth is on the tilted axis. This is the equator, Tropic of Cancer, Tropic of Capricorn. And here you can see that as the north pole is away from the direct or vertical rays of the sun, so it is winter in the northern hemisphere. The nights are longer than the day. But whereas in the southern hemisphere, where the south pole is vertical towards the sun, so the days are long and the nights are short. So that's the reason why there is difference in the temperature. There is also difference in the climate and climatic conditions. This is all because of the inclined axis of the earth. Let's pass on to revolution of the earth, which is the movement of the earth around the sun in an elliptical orbit. The characteristics of a revolution. The earth goes round the sun in an elliptical orbit, which is not circular. The earth's movement speedens on coming close to the sun due to gravity. This is a very, very important point that you should note. on Earth coming close to the Sun, its movement speedens. The Earth completes one revolution in 365 days, 5 hours and 48 minutes. The Earth rotates on its inclined axis of 66 degrees with regards to the base or the orbital plane. So the time taken by the Earth to complete one revolution is 365 days, but 5 hours and 48 minutes equally distributed and added to 4 years make one leap year. So that is why once in 4 years there is one leap year. Leap year means the year where February has 29 days. Effects of revolution. Seasonal changes. Sun's angle of inclination determines the temperature of a place. If a place is receiving the vertical rays of the sun is massively heated, any place that receives oblique rays of the sun or the slant rays of the sun is not that heated or is moderately heated. The tilted axis of the earth causes seasons due to uneven distribution of heat, and revolution around the sun is on an annual scale. This is because the earth takes 365 days or 1 year to complete one revolution. As the part of effects of revolution, the positioning of the earth with regards to the sun, like there are two positions, one is known as the perihelion and other one is known as the aphelion. Perihelion is the position of the earth where it is closest to the sun. Perihelion is the position of the earth closest to the sun, whereas aphelion is the position of the earth with a far distance or far off distance, or where there is a long gap between the earth and the sun. So coming back, perihelion, the earth's closest position to the sun on 3rd January. Okay, it is winter in the northern hemisphere. Why? Because the northern hemisphere is away from the vertical rays of the sun, whereas aphelion is the farthest position to the sun on July 4th. The effect of revolution also creates heat zones. Heat zones are also known as the thermal zones. The earth receives the sun's heat at different angles at different places because the spherical shape, revolution round the sun in elliptical orbit. So these are the two important factors that makes the earth to receive the temperature of the earth at differential rates. Basically, there are 3 thermal zones on the earth divided based on its latitudes. For example, 0 to 23.5 degrees north and south of the equator is known as the torrid zone because the torrid zone receives the vertical rays of the sun, whereas 23 degrees north to 66.5 degrees north, 23.5 degrees south to 66.5 degrees south is known as the temperate zone. Why? Because this zone receives moderately oblique rays of the sun. So here the temperature is quite moderate, but whereas 66.5 degrees to 90 degrees north and south of the equator is known as the frigid zone. Why? Because here the rate of heating is once in 6 months. So generally polar regions are snow covered because the sun rays and temperature doesn't influence. So torrid zone, 23.5 degrees north to 23.5 degrees south, receives vertical rays of the sun, remains warm throughout the year. Temperate zone, 23.5 degrees to 66.5 degrees north and south of the equator, receives oblique rays of the sun, remains moderately warm. Frigid zone, 66.5 degrees to 90 degrees north and south of the equator, receives extremely oblique rays of the sun, remains extremely cold throughout the year. So this is how the rotation and the revolution has influenced the thermal zones on the earth. As Going ahead, learning the effects of revolution, solstice and equinoxes are again the different positions while the earth is going around the sun. Solstice is the location of the earth on 21st June where the north pole is tilted towards the sun. Can you see? 21st June, summer solstice, where the north pole is tilted towards the sun. So, hence, it is summer in the northern hemisphere. So, this position is known as the summer solstice. Whereas, December 22nd, you can see that the south pole is vertical to the sun. So, hence, it is summer in the southern hemisphere and winter in the northern hemisphere. So, this position of the earth is known as the winter solstice. Why? Because it's winter in the northern hemisphere. Equinox is the position where 2 days in a year the sun is vertical over the equator. These days are 21st March, known as the spring or the vernal equinox, and 23rd September, known as the autumnal equinox. So during these days, that is 21st March, the days and the nights are equal in length throughout the world. It is spring in the northern hemisphere. Whereas 23rd September, autumnal equinox, the days and nights are equal in length throughout the world. It is autumn in the northern hemisphere. So when it is spring in the northern hemisphere, it is autumn in the southern hemisphere, and when it is autumn in the northern hemisphere, it is spring in the southern hemisphere. So the seasons are the outcome of differential rate of heating of the earth's surface. This is because the earth is spherical in shape, and as discussed earlier, that it is only the equator that receives the vertical rays of the sun, and as you move towards the poles, both right from the north to south, the angle of inclination of the sun decreases. So here there is a simple example or the illustration. You can see that the rays of the sun is always vertical, that is 90 degree along the equator. What can be the angle of inclination at the latitude? 10 degrees. So the simple thing, you'll have to just subtract 90 minus 10, that means 80 degrees. So the angle of incidence of the sun's ray is 80 degrees along 10 degrees Celsius. So it keeps on decreasing towards the pole. So towards the north pole, the angle of inclination becomes nil. So that's the reason why the polar regions are snow covered, because of the extreme low temperature. So equinox and solstice are the positions of the sun that helps us to understand seasonal reversal in the northern and the southern hemisphere. So when it is summer in the northern hemisphere, it is winter in the southern hemisphere. This is because in alternate turns, when it is summer in the northern hemisphere, it is winter in the southern hemisphere. Why? Because the south pole is away from the indirect rays of the sun, and vice versa. When it is winter in the southern hemisphere, it is summer in the northern hemisphere. So when it is summer in the northern hemisphere, it is winter in the southern hemisphere. So this keeps shifting in turns. So basically there are 4 seasons, namely spring, summer, autumn and winter. So the earth's position on 21st June, known as the summer solstice, if you carefully look, you can see that the north pole is inclined towards the sun. So that's the reason why the northern hemisphere is experiencing summer, whereas the southern hemisphere, which is away from the influence of the direct rays of the sun, it is winter. So summer solstice in the northern hemisphere, the rays of the sun is vertical over Tropic of Cancer, 24 hours day beyond the Arctic Circle. That means in the Arctic Circle, the length of the day is 24 hours. So this zone or region is known as the land of midnight sun. So hence, when it is summer in the northern hemisphere, it is winter in the southern hemisphere. So this positioning of the earth is known as what? Summer solstice. The earth's position on 22nd December. You can see that the south pole is vertical towards the sun. So the southern hemisphere is experiencing winter, whereas the north pole is away from the direct rays of the sun. So hence it is winter in the northern hemisphere. So this positioning of the earth is known as the winter solstice. Why? Because in the northern hemisphere it is winter. The rays of the sun is vertical over the Tropic of Capricorn. The south pole has 24 hours of day. Why? Because it is totally inclined and vertical towards the sun. So hence summer in the southern hemisphere and midnight sun is experienced by the navigators. So here experiencing midnight sun is not possible. Why? Because as you all know that southern hemisphere has vast expanses of water than the land. So hence the midnight sun can be witnessed only by the navigators. The earth's position on 21st March, you know that the sun moves or migrates towards the equator. The days and nights are equal in length. This is because the sun becomes vertical over the equator, so there is an equal distribution of heat and light on both the hemispheres. It is spring in the northern hemisphere. I just told you earlier, when it is spring in the northern hemisphere, it will be autumn in the southern hemisphere. Passing on to the next, the earth's position on 23rd September. The sun is vertical over the equator. The days and nights are equal. It is autumn in the northern hemisphere. So when it is autumn in the northern hemisphere, it is spring in the southern hemisphere. So these are various effects of rotation and revolution of the earth. And students, that you are supposed to know is the diffuse light between the sunset and the complete darkness. Sunset in the evenings, the sunset and the complete darkness is known as dusk, D-U-S-K, and twilight, T-W-I-L-I-G-H-T. And the diffused light between sunrise and a full daylight. That means at the time where the sun is rising and when the sun is fully over the sky, giving full light, is known as dawn. So students, this is what we have learned in this chapter. So to sum up, what we have learned in this chapter is the two motions of the earth, rotation and revolution. Rotation means the movement of the earth on its own axis from west to east, whereas revolution is the movement of the earth round the sun in an elliptical orbit. Rotation causes day and night, whereas revolution give rise to the seasons, and at the same time it also splits or divides the earth into different thermal zones, and that give rise to the wind system and the ocean currents that has impact on the climate and climatic conditions of different places on the earth. Thank you.